Hi, my name is Eric Jamois. Thank you for joining me in this ADMET Predictor interactive tutorial dedicated to substructure and Marcouche searching. Our topic for today will focus on the cheminformatic functions of ADMET Predictor. So we're going to cover explicit substructure searching, but also Marcouche searching. And we will also see how you can analyze data sets using smarts filters. So we'll see how we can use some of the pre-built filters that have been included with the software, but also how you can make your own. So we're going to start with the substructure search aspect, and we're going to load a file of a little bit over 10,000 compounds, which is this enamine diversity set. So we're going to open this set of about just again a little bit over 10,000 compounds. And the first thing we're going to do is to look for compounds that contain a pyridine ring. And one of the ways you can do this in the software is under Edit. You have the ability to query by substructure, by structure, and also by property. The quick keyboard shortcut for this is Control Q. Okay. Right. And you have multiple ways by which you can enter this query. The really easy way to do it is through MetChem Designer. So you have this MetChem Designer option here, and if we want to query for a pyridine ring, we can very simply sketch a pyridine ring, okay? And then the way we transfer it back to the substructure search window is by pressing this left arrow keys that says transfer the structure back to the caller, okay? And there's different functions here to use exact matching or substructure matching, etc. So for the purpose of this exercise, we're going to look for, again, substructures within this molecule, this set of molecules containing a pyridine ring. So we've set our search here, and all we need to do is to click OK. So that will start the search. It's actually very fast, as you've seen, barely the blink of an eye, and it's returned the set of compounds that contain a pyridine ring. These compounds are highlighted here, so we could just go down the list and see the compounds that contain a pyridine ring. One of the easy things you can do is actually store that as a column. And if you go to one of the selected compounds and go to modify attributes, you can add an attribute that corresponds to the presence of the pyridine ring. So you can say add attribute. This is going to be a constant value, okay? And in this case, it's going to be a text. The attribute name is going to be pyridine. And since these are the compounds containing, we're going to say yes, it contains one or multiple pyridine rings. So we've added a pyridine column here, again, with the compounds actually containing one or multiple pyridine rings, getting a yes annotation within that column. And now if we want to revert that selection, there is a very easy way to, with Control I, that's a keyboard shortcut, Control I allows you to invert that selection. So now we're selecting all the compounds that don't contain any pyridine ring. And the same thing, we're going to say modify attribute. So right mouse click on one of those compounds, add attributes, constant value, and this time we're going to say no and O. No. Okay. And we really don't need the selections anymore. To deselect everything, you can either go under Edit, Deselect All, and that maps to Control D for deselect. So Control D, we have nothing selected anymore. So one of the interesting things you can do in Chart 1 is to plot the compounds that contain one or multiple pyridine rings. So this is a categorical column. Obviously, it says yes or no, but it will display in ADMET Predictor as being a yes or no. And by clicking on this column now with your left mouse button, you can see that you've got 1,783 compounds which contain a pyridine ring. And then you can just go through all of these compounds and notice that it's also displaying for you the available compound attributes for these molecules. So, okay, so we're going to shift gears a little bit now and get into something a little bit more sophisticated, which is a Marcouche search. Okay, so what we're going to do now is we're going to search for compounds that contain either one or multiple three-membered rings, but three-membered rings which can be of different kinds. So either a cyclopropane or an epoxide or the nitrogen equivalent, which is an aziridine. Okay, so, and we're actually going to use a shortcut way of doing this. Previously, we used the edit query by substructure. That's what we did before. There's a different way of doing this, which is a little bit faster. And that involves using the attributes function. So, and that is found under data, okay? You can directly add compound attributes corresponding to a query. So again, under data, add compound attributes, and now you would select query, okay? Now we're going to clear this query. We're going to our previous query, which was this pyridine ring. And similarly, we're going to go into MedChem Designer, okay, and enter our basic cyclopropane ring here, but we're going to make our selection a Marcouche structure by selecting this atom here. And instead of selecting set atom type, we're going to allow multiple atom types to map to this location. So we're going to allow a cyclopropane, an aziridine, that's the nitrogen, or an epoxide, that's the oxygen. Okay, and this now becomes our Marcouche structure that we are, in a similar way that we've done before, we're sending it back to the caller, and this is now our query element. And we will give it a name a little bit more explicit than molecule 2. And we're going to call it 3MB ring. Okay. And we're going to say OK. And our structures come back, and we can easily rank them. So now we have a new column, which says 3MB ring, and we can sort based on this column. So we see that there are some molecules that contain 3, others that contain 2, and many that contain none. Now, if we want to do a similar graph as what we've obtained before, similarly, we can use chart 1, now using the 3-member ring column, and we've got either 0, again, the majority of the compounds don't contain any 3-membered rings. They can have 1, 2, or 3. And if we click on one of these, then we can see, for example, the compounds that have 3-membered rings, and there's only 2 of them. Okay, so again, it's just a very easy way to have access to these compounds.